Hello, everyone, and welcome back to M155 Quantitative Reasoning Mathematical Modeling. In the previous video, we looked at statistical studies, samples, and bias, where we dealt with statistics, variables, populations, samples. Okay, the main idea was simple. Before trusting a statistic, ask who was studied and how the data was collected. Today, we're going to take data and organize it using frequency tables and graphs. Let's get right into the questions. So, first of all, example number one, and again, you can review those terms at your own leisure. We're going to try to make these videos a little bit more concise. All right, so example number one, build a frequency table. We are given these commute times, okay? We have 5, 12, 17, 18, 22, 27, 31, and 38. We want to group them into 10-minute intervals. So what we want to do is use 0 to 9, 10 to 19, 20 to 29, 30 to 39, okay? So again, we have our terms, right? And we want to group them into 10-minute intervals. So notice here is our 10-minute intervals. We have a 10-minute window here, 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 and here. This is 39, okay? Now we have to count how many values fall into each group, okay? So we have our intervals, okay? And now we want to calculate how many values fall into each group. Okay, so between this window we have 5, right? So the frequency of this particular one would just be 1, right? We just have that 5 that's going to occur within that window, right? And then we in the next interval 10 to 19 we have 12, 17, and 18. So that gives us a frequency of 3. And then between the window 2029, we have 22 and 27. So that's a frequency of 2. And then 30 and 39, we have 2 as well. We have a frequency of 2. We have 31 and 38. Okay. So 10-minute intervals, frequency, that means how many times they occur. So our table is 0 to 9, 1, 10 to 19, 3, 20 to 29, there's 2, 30 to 39, there's 2. Okay. Now what we're going to do is we want to add those up. Okay. So we're going to start with 1, 3, 2, and 8. Okay. So 1 plus 3 plus 2 plus 2 is going to give us 8. So that means 8 data values, right? So 8 data values. Okay. Now, that essentially concludes that because we know that we have 1, 2, 3, 4, 5, 6, 7, 8. So the frequency is correct and the 10-minute interval is correct. And all we had to do was just group commute times together in 10-minute intervals. So that's what we did here. So I just double back to check the frequency to make sure that corresponded with the number of points. So anytime you're doing a frequency table, just make sure that the total number of frequencies is how many data values you have at the end. All right. Example number 2, convert the class counts in a frequency table to proportions or percentages. Okay, now let's turn these counts into percentages. Okay, we're going to use the data from our previous question. And so, in order to do that, what we need is this is asking for something called the relative frequency. Okay. And that relative frequency is equal to the frequency count divided by the total number. Okay. So our total number, right, we looked at was n equals 8, right? N is equal to 8 because that was how much data values we had. So what we want to do is for 0 to 9, right? I'm just going to write up here. For 0 to 9, we have a relative frequency because we had 1, which is 1 over 8, which is equal to 0.125. That's also basically 12.5%, right? And let me just move down here. We have um, the 10 out of 19 group. The 10 out of 19 group, we had 3 out of 8, which is 0.375 or 37.5%. And then for the 20 out of 29 group, we have 2 out of 8, which is 1/4. So that's 0.25 or 25%. And the same was true for 30 out of 39. 30 out of 39 was also 25% or 2 out of 8. Or that's also, you can reduce it to 1/4. Okay. So we have all of our percents: 25%, 25%, 37.5%, 25.5%. Okay. So those are what is called relative frequencies. Okay. And then we can check these values and add them up. So if we did 37.5 plus this, that'd be 38. 38 plus 12 would be 50, right? 50 plus 50 would be 100%. So to check our relative frequency to make sure we are on the right track, it must become 100%. Okay. And so again, this is relative frequency. Relative frequency is the frequency total of each group. So 1 divided by 8, 3 over 8, 2 over 8, 2 over 8. And again, this is called relative frequency. Okay. All right. You can try this problem at the bottom. Which group should we use for political party? Political party is made up of categories, right? So what we should use is basically a bar graph, right? I would use a bar graph for this one, right? Um, what about household income? Okay, so we're choosing a bar graph or a histograph for either one of these. I would use a bar graph for the political party. Okay, and out for the household income, since income is numerical, we can group it into intervals. So I would use a histograph for income. Okay. So histograph for income, since this is numerical, and then we can calculate the frequency, like how much are we spending on groceries relative to our income? You know what I mean? How much are we spending on childcare relative to our income? So that would be something that a histograph could use. And then with respect to a political party, you can use a bar graph, like how many people voted Democrat, how many people, what ethnicity, what was their income. You can use, you don't, you don't essentially need intervals for those things. Okay, so with respect to categories, bar graph, numerical intervals, histograph. Okay, okay. Example number 3. A cumulative table shows 72 of 100 observations at or below 30. State the cumulative percentage. So suppose the table says, you got 72 out of 100 observations, right? And they're at below 30. What percentage is that? So the way we would do that would be 72 divided by 100 times 100%. Well, that's just 72%, okay? Because this will be 0.72, then move the decimal two places, 72%. So the question, or excuse me, the answer is 72% of the observations are at or below 30. Okay. Example number 4. Use histographs. All right. Suppose you have two histographs. Use the exact same data, but one uses suppose let me see. I'm sorry. Suppose two histographs use the same exact data, but one uses smaller intervals and the other one uses larger ones. Can the graphs look different? Well, the answer would be yes, right? So, for example, one histograph, let's just say, histograph A. I'm gonna abbreviate. Histograph A may use uh 0 to 9, 10 to 19, uh 20 to 29, right? And then another one might use, let's just say, hist- histog- histograph B may use, let's say, 0 to 19, and then 20 to 39, and then 40 to, what is it going up by? We'll just say 40 to 59, right? So the wider intervals combine more data together, right? Because you're going to have, let's just say we use the same study that we used earlier in the first example. Well, you're going to have like one relative frequency. So it'll be 1/8. Then under here, what was there out of 19? Let's see. Between 0 and 19, there was, let's see, 1, 2, 3, 4. That would be 4/8. So notice how the frequency would change. You know what I mean? So absolutely, the wider intervals would combine more data. So the shape of the graph can look different, even though the data is the same. Okay, so the data can look the same, but if you're using different intervals, that is going to be a factor. So always look at the interval width before interpreting a histograph. Like what are the intervals in this particular histograph, right? Common mistake. Suppose a student uses 0 to 9, 11 to 20, 22 to 30. What's wrong with that? Okay. Well, we are missing 10, okay? It says correct the class intervals, right? So we're missing 10. Where is 10? Okay? Where are you? Right? Where's 10 located? We don't even see it. And where is 21? Right? Where is 21 as well? So what we have to do is basically fix their class system. So their intervals should be based on a base 10, right? If they're going to 30, okay, or even beyond, we could use 10. So let's just do that. 0 to 9, 10 to 19, 20 to 29, 30 to 39. Because even if like, okay, we go up to 30, that means there's going to be potentially one that would hit 30. Or I'm just, giving a hypothetical. And so if we're using a base 10, we would still do the 30 to 39. That way we would be able to calculate even if there's just one that would fit into that interval. Okay? So that's it for this lesson. Remember, relative frequency is equal to the total, or excuse me, is equal to the frequency or the number of times something occurs in an interval divided by the total. Okay. And with respect to categories, as a matter of fact, with respect to categories, right, you would use a bar graph. And with respect to numerical intervals, you would use a histograph. Okay. And always check how those intervals are structured, right? Are they structuring the intervals like this, well, that's a problem because you need to include the, you know, number 10 and number 21. All right, so pay attention to those things. In the next video, we'll look at how graphs and statistics can be presented in ways that make the data appear more dramatic or even less dramatic than they really are. Okay, thank you for watching, and I'll see you in the next one.